Today, we're back in Los Angeles to catch a glimpse of the Endeavour Space Shuttle at the California Science Center before it says goodbye to public view later this year. The Samuel Oschin Air and Space Center won't be ready for a few more years, so don't miss the chance to see Endeavour now. Also be diving into the awesome World of Life exhibit, exploring ecosystems, and checking out the Air and Space exhibit. Join us for an exciting day of discovery. As you walk from the parking lot to the Science Center, don't miss the giant lever exhibit. Imagine lifting a massive 6,645-pound pickup truck. Well, now, you don't have to. Use your lever know how to guess which rope makes lifting this beast the easiest. If you're not sure, give all the ropes a pull. You'll find helpful hints all around you. Don't pass up on this hands-on challenge. It's your chance to earn some serious bragging rights. Afterwards, take a look around the parking area and you'll notice that it's surrounded by gardens showcasing the incredible biodiversity of Southern California. Make sure to also check out the unique A-12 trainer, the only one ever made. Unlike the regular A-12, this special aircraft had room for both a pilot and an instructor. It's a variation of the famous SR-71 Blackbird, a legendary reconnaissance plane from the Cold War era. On your way to the entrance, you'll walk through the Robert H. Lorsch Family Pavilion, a remarkable outdoor spot right next to the IMAX with Laser Theater. Here, you can dive into a 3D IMAX venture and explore new worlds in an immersive experience. Check out the latest shows and showtimes and grab your tickets online at the official California Science Center website. As you walk into the Science Center, look up and you'll see the T-38 jet and the F-20 Tigershark fighter hanging out on the roof. The T-38 is the first twin-engine supersonic jet trainer still going strong in the U.S. Air Force for training and chasing. It's about 25 feet wide, 46 feet long, and can hit max speed of Mach 1.3. Fun fact, planes faster than Mach 1.2 can make sonic booms. Now, imagine the roar of the F-20 Tigershark clocking in at Mach 2. It was designed to be reliable, easy to fly, and inexpensive to maintain, but never made it to mass production. So this speedy prototype, soaring at 53,800 feet per minute, is truly one of a kind and the last remaining. Now, let's head over to the Sketch Foundation Gallery's Air and Space exhibit. This exhibit has fascinating displays both inside and outside. Inside, there's the Humans in Space panel, which discusses the 4 deadly hazards of space. First off, humans need air pressure and breathable oxygen to survive, and space has neither because it's a vacuum. That's why spacesuits are vital for survival. Ever wonder what would happen without a spacesuit? Forget the sudden movie explosions. You'd just pass out in 10 seconds and die from exposure after several minutes. Secondly, astronauts in space need protection from speedy meteoroids. They are tiny rock dust and other space debris orbiting around Earth at over 17,000 miles an hour. Even something as small as a grain of sand can cause massive trouble. These micrometeoroids come from passing comets, asteroids, or even leftover bits from past missions. Good news though, spacecraft hulls and sturdy layers in spacesuits can slow down and block these little troublemakers. Number 3 on the space danger list is none other than space radiation. Regular light and radio waves, not a problem. The tricky part is X-rays and supercharged particles from the sun and deep space that have enough energy to kill our cells and damage our genes. So, if you're thinking slapping on extra sunscreen will do the trick, think again. Sunscreen works great on Earth, where our atmosphere shields us from most of these waves. But up in space, not so much. Space, as we've come to understand, is highly unpredictable. The weather up there doesn't only make sunny spots dangerous, even the shady spots can be just as deadly. Sunlight can crank up a spacesuit to a scorching 250 degrees Fahrenheit in seconds, while the shadows can plunge the temperature to a freezing negative 240 degrees Fahrenheit. A spacesuit keeps astronauts safe with enough insulation, preventing them from turning into human popsicles or roasting like marshmallows, and a spacecraft can stabilize temperatures to livable conditions. Check out this spacesuit worn by Apollo 16 Command Module pilot Thomas K. Mattingly. It might seem basic on the outside, but it's made of 21 layers weighing a substantial 185 pounds on Earth. Meet the Project Mercury Test Training Suit, made in the 1960s, weighing in at a mere 20 pounds. This suit is pressurized and made of rubber and nylon. The shiny, aluminized coating is applied to reflect heat away from the astronaut's body. However, this suit was not designed for use outside the spacecraft and only protected the earlier astronauts if their orbital capsule lost pressure. Before we explore the space telescope models, let's briefly go over the different kinds of energy given off by objects in space. Stars, those shining wonders in our sky, don't just dazzle us with visible light, they're also emitting radio, infrared, ultraviolet, X-rays, and even gamma rays. Each of these wavelengths reveals different secrets of celestial objects. This exhibit shows us the difference between the size of wavelengths and which telescopes are used to capture them. This 1/5 scale model of the Hubble telescope has helped astronomers measure the age of the universe and peek into gas clouds where young stars and planets are born. The full-size Hubble is as big as a school bus, still cruising in space and sending more data. So, why are some telescopes based on Earth and others are orbiting in space? Well, that's because an orbiting telescope is able to ride above Earth's atmosphere. Down here, our atmosphere bounces around light. That can blur images taken by telescopes on the ground. But Hubble, out in space, can get sharp, detailed pictures of distant stars and galaxies, free of the twinkling we see on Earth. Here we have a model of the Chandra Space Telescope, which orbits Earth to look at high-energy X-ray light from stars and galaxies. X-rays play by their own set of rules. They're not able to go through our atmosphere and they don't reflect off a mirror the way normal light does. That's why Chandra's mirrors are special, shaped like smooth glass barrels. Incoming X-rays slide off the inside, focusing to a point. These X-rays show details our eyes can't see. Take the Crab Nebula, for instance. In regular light on the left, it's a 1,000-year-old supernova relic. But in the X-ray close-up on the right, peek into the hidden heart complete with a fast-spinning star, rings of hot matter and twin energy jets shooting from its poles. Meet the Mini-Iris satellite, the first telescope to measure infrared wavelengths from orbit. Did you know? Everything emits infrared light, even though it's invisible to our eyes. Well, some things in space appear only in infrared, especially cooler objects and dust warmed by stars. For example, look at this image of the constellation Orion seen in visible light compared to the false color infrared image on the right. Dark, interstellar dust shines bright in the infrared, warmed by nearby young stars. IRIS was able to find hundreds of thousands of objects in a mere 10 months before running out of cool liquid helium for its sensors. It unveiled stardust disks, 6 new comets, and even gave us the first clear glimpse of our galaxy's core. This is the Aero B nose cone, which is a payload launched in a small-sounding rocket. It was sent up and recovered 3 times in the early 1960s. What was it up to? Well, it had a spectrograph inside that measured the sun in ultraviolet light and in X-ray. The sun's hot outer corona shines in X-rays light. The Aero B nose cone's missions lasted approximately 15 minutes. After the booster rocket separated, the nose cone would de-spin and open its doors. The internal experiment adjusted to stay focused on the sun during its brief time above the atmosphere. Finally, the nose cone gracefully parachuted down, often landing in the desert or the ocean. Let's head over to the outside exhibits. This is the actual command module from the Apollo-Soyuz mission, symbolizing a significant moment in space history. Originally intended for a lunar mission, the module was repurposed for the groundbreaking Apollo-Soyuz rendezvous when Apollo 18 faced budget cuts. This mission marked the first collaboration between the Soviet Union and the United States in space, signifying a shift from competition to cooperation. The objective was to test docking systems, addressing challenges such as atmospheric pressure differences. The success of this joint mission laid the foundation for future international partnerships in space exploration. Right here is the Gemini 11 capsule, which was part of the mission that gave us the first view of the Earth as a sphere and the first American flight to have a computer-controlled re-entry. Gemini's goals? Send humans and gear into space for up to 2 weeks. Master rendezvous and docking with orbiting vehicles. Move the dock duo using a propulsion system. perfect the art of re-entry, and land precisely where planned. Oh, and let's not forget, it aimed to gather more intel on how weightlessness affects our astronauts and track their health during those long-haul flights. And this, here at the bottom of the craft, is the pattern that was burned into the heat shield when the capsule re-entered the Earth's atmosphere. During re-entry, friction with the atmosphere heated the shield of fiberglass and resin up to 3,500 degrees Fahrenheit. The outer surface vaporized, leaving behind a black carbon residue pattern. The pattern isn't in center because the capsule entered the atmosphere at an angle, which helps give it lift like a wing, and the commander could adjust the re-entry flight path if needed. The Mercury Redstone 2 mission tested everything from rockets to capsules to ensure a safe journey for the first American astronaut into space. But guess who stole the spotlight? None other than a 4-year-old chimpanzee named Ham. Chosen specifically from a colony of 6 astrochimps, Ham boldly faced challenges to see if humans could survive space's wild conditions. Ham aced his mission, paving the cosmic runway for Alan Shepard, the first American astronaut to rocket into suborbital space in May 1961. But Ham wasn't the only trailblazing chimp. Meet Enos, another spacefaring simian who tested the first orbiting Mercury capsule in November 1961. His mission: clear the way for John Glenn to become the first American to orbit Earth in February 1962. The MR2 capsule on display is the actual one that took Ham to space. Look inside and you'll catch a glimpse of the very couch Ham lounged on during his historic flight. Oh, and that couch outside? That's the seat used by Enos himself. All right, time to buckle up for a mission to the planet segment of this exhibit. Now, we all know reaching planets ourselves is a bit tricky, so what's the next best thing? Satellites, probes, and rovers to gather information about our closest cosmic neighbors. Specialized spacecraft, like Cassini, were designed for specific missions. Cassini, the largest interplanetary spacecraft launched by NASA, was engineered to orbit Saturn. Utilizing a complex maneuver, it slipped through the planet's rings and became captured by its gravity. Cassini also launched the European Space Agency's Huygens probe, which explored Saturn's moon, Titan, capturing unprecedented photos of its surface. Cassini's mission, initiated in July 2004, provided extensive data from gravitational field exams to surface mapping on Titan, concluding with a deliberate plunge into Saturn's atmosphere in 2017. The Cassini spacecraft and the Huygens probe on display are full-scale engineering models, and you can clearly see the insulating blankets on the outside, which protected the craft from malfunctioning. Meet the Viking 1 lander, the first successful U.S. spacecraft on Mars. Along with Viking 2, it provided over 50,000 images of the red planet. In fact, before the missions, scientists were thinking Martian skies would be deep blue, like our own upper atmosphere. Well, guess what the Viking pics revealed? Mars' stunning salmon-hued sky. The primary mission goal was to explore the possibility of past life on Mars. While evidence was not found, they determined that many of the necessary ingredients for life were present on the planet, leaving the intriguing questions frustratingly unanswered. Subsequent Mars missions, including Pathfinder, Spirit, Opportunity, Curiosity, Insight, and Perseverance, build on Viking technology. Even 35 years later, scientists continue to analyze data from the Viking missions. The Science Center also houses several early aircrafts, and among them is the Veli Monocoupe 70, a pioneer in planes designed for private pilots by WLVUE. The single-wing monocoupes were built with a frame of wood and covered the shell with canvas, offering seating for 2. Its enclosed cabin, speed, and flashy style made it quite popular. From 1927 to 1929, approximately 350 monocoupes took to the skies. Behold, a replica of the 1902 Wright glider, the groundbreaking aircraft that propelled Orville and Wilbur Wright into the realm of controlled flight. These two pioneers were no ordinary duo. Their journey to invent the airplane involved meticulous engineering tests and an extensive collection of data. They focus on the mechanics of flight, prioritizing safe aircraft control. Testing just above the ground, they refine their approach, ultimately leading to the development of the vastly improved 1902 glider. Now, let's make our way to the far end of the second floor. This is where the captivating World of Life exhibit unfolds, offering a fresh perspective on the living world, from an intimate exploration of the tiniest creatures to a larger-than-life encounter with the intricacies of the human body. In the Life Beginnings portion of the exhibit, discover the mysteries of reproduction, development, and the gene passage for humans and all living creatures. Take a step into an immersive womb room, where you'll encounter the human journey from conception to birth, alongside the awe-inspiring sight of authentic fetal specimen. Let's move on to experience the beauty of life through a microscope with stunning images from the Nikon Small World Photography Competition. Here, you can observe how living things work through enlarged images of flowers, insects, and cell. You can also examine real specimens under a microscope, test your skills in a microscope mystery challenge, and even pose for a selfie with a human cell magnified to 100,000 times its natural size. It's a great opportunity to learn about the tools and techniques that let scientists see smaller, transforming the way you look at life. Step into the Bodyworks Theater and be introduced to TESS, the incredible 50-foot human body simulator. Immerse yourself in a captivating 15-minute show, brimming with animatronics, animation, and special effects. Post-show, make your way to the adjacent room featuring the Plants and Animals exhibit. Here, you'll have the chance to encounter a variety of animals residing in terrariums tailored to their exact biological needs. There's also the World of Life Discovery Room, specially designed for the younger visitors from 7 years of age and under. Finally, make your way to the Cell Lab, which explores the question, what does it take to be alive? Discover what all living things have in common and learn about different types of these essential building blocks, each with its own special job. After exploring the intricacies of life, shift your focus to the diverse ecosystems at the Science Center's Ecosystem exhibit. This exhibit highlights the delicate balance of the environment, with 10 zones exploring different ecological principles. On the second floor, you can explore zones like islands, deep-sea vents, poles, the desert, and the rocky shore. The outdoor component, begin your exploration at the island zone, where the focus is on understanding evolution through the study of unique animals residing in isolated habitats. Observe live lizards and tropical fish in reef environments. Engage with interactive exhibits to enhance the overall learning experience and make the visit enjoyable. Explore the extreme zones of the ecosystem, such as the deep-sea vents, desert, poles, and rocky shore. The deep-sea vents, located in the darkest and least explored areas of the ocean floor, host unique adaptations of animals that can survive in the absence of sunlight and withstand immense water pressure, making this ecosystem otherworldly and challenging for most living organisms. Discover the challenges of desert life, marked by rare and unpredictable rainfall and extreme temperature fluctuations. Despite these harsh conditions, desert animals and plants have adapted unique survival strategies, often hiding or shutting down during the hottest, driest period. Explore the Southwestern Desert exhibit to understand how life thrives in this extreme environment, featuring live animals like desert tortoises, chuckwallas, Gila monsters, honeypot ants, scorpions, and phoenix foxes. Surviving at the poles, with freezing temperatures, relentless winds, and extended periods of darkness poses significant challenges. Some Arctic and Antarctic organisms have developed adaptations to thrive in these harsh conditions. However, the polar regions are highly vulnerable to climate change, evidenced by rising temperatures, melting ice, and disruptions to the food chain. Explore the Polar Research Station to understand how life copes with the cold and witness the impacts of climate change on these ecosystems. Engage with interactive elements, such as a snowmobile experience and a giant ice wall, and learn about the distinct habitats of penguins and polar bears in the wild. Explore the Rocky Shore Zone, situated outside the building, where life deals with challenging conditions such as pounding waves, competition for space, and extended periods out of water. Witness how plants and animals on the rocky shore have adapted over time to cope with these extremes. The exhibit showcases live animals, including sea stars, anemones, sea urchins, limpets, and more, providing a fascinating glimpse into the resilience and adaptations of life in this dynamic environment. Conclude your exploration inside with the Los Angeles urban habitat, where questions about waste disposal, water sources, and energy are addressed. Dive into the world of urban ecology, investigating how wild animals navigate the challenges of living in urban settings amidst a blend of natural and man-made environments that define the Los Angeles area. Don't forget to explore the special exhibit, Jane's Endangered Animal Experience, inspired by the Apple TV show Jane. This hands-on experience focuses on educating visitors about the North American honeybee. Engage in activities such as flying in a replica of Jane's high-tech pod vehicle to collect pollen and evade predators. Additionally, climb onto a kid-sized model of a bee to gain a close and personal understanding of the remarkable aspects of these tiny creatures. The Endeavour Together experience is the last exhibit on the second floor. It pays tribute to the Endeavour Space Shuttle program and the individuals integral to its success, focusing on California's significant role as the birthplace of all orbiters. The exhibit showcases images of Endeavour's construction in Palmdale and Downey. It includes artifacts that ventured into space aboard Endeavour and offers insight into the external tank's relocation from New Orleans to the California Science Center. Engage with dramatic video programs depicting Endeavour's journey to the center and the external tank's passage through the city. Experience the contributions of Space Shuttle Endeavour to the space program through a state-of-the-art motion simulation. You can access the first-floor exhibits and the Space Shuttle Endeavour building via the second-floor elevator. The first floor features the rest of the remaining ecosystem exhibits, and then we will finally head to the building housing the Endeavour. You can discover the impact of water in the river zone, exploring its ability to shape landscapes, carve mountains, and influence the creatures within it. Interact with hands-on experiments to understand the fundamental forces shaping Earth, as well as the flow of energy and matter across the planet in this interactive exhibit. The Rot Room offers a fascinating experience as you observe roaches, sow-bugs, millipedes, and best bugs transforming a log into decaying wood. Observe the process of decomposition by examining maggots and domestic beetles feeding on deceased organisms. This exhibit provides a close-up look at how materials break down, showcasing the cycle of life and decomposition. In the global zone, witness Earth's intricate cycles of air, water, land, and life on the Magic Planet interactive globe. Recognize Earth as a complex ecosystem and receive an introduction to the impact of climate change on our planet. Passing through the atrium, immerse yourself in the breathtaking beauty of a giant kelp forest, where kelp, similar to trees, creates a habitat supporting a diverse range of life. Surprisingly, this spectacular ecosystem, hosting over 800 species in the wild, can be found off the Southern California coast. Peer into the 188,000-gallon tank to witness life in these unique underwater forests, and use iPads to identify and learn more about the species present. The exhibit showcases live animals like leopard sharks, horn sharks, moray eels, giant sea bass, rockfish, spiny lobsters, anemones, and more. Explore the Space Shuttle Endeavour after touring the first-floor ecosystem zones. Follow the signs and head to the Samuel Oschin Pavilion, where you can get up close to Endeavour. As NASA's fifth and final space shuttle, the shuttle boasts a legacy of historic missions and groundbreaking achievements. Endeavour embarked on its space journey on May 7, 1992, and played a crucial part in putting together and looking after the International Space Station, making significant contributions to building humanity's space outpost. One of its most celebrated missions involved the servicing of the Hubble Space Telescope in December 1993. Endeavour's crew successfully repaired and upgraded the telescope, enhancing its observational capabilities and extending its lifespan, leaving a lasting mark on the world of astronomy. The shuttle's adaptability was showcased during the STS-118 mission in 2007, emphasizing the importance of education in space exploration. Carrying educator astronaut Barbara Morgan, this mission underlined Endeavour's role as a symbol of inspiration and the boundless potential of knowledge beyond our planet. Did you know that the Endeavour holds the record for the longest shuttle mission? It lasted an impressive 12 days, 17 hours, and 55 minutes. However, even upon its retirement in 2011, Endeavour embarked on a final journey, a cross-country tour allowing people across the United States to witness the shuttle one last time. But here's the scoop. The exhibit is only open to the public until December 31st, 2023. But don't worry, it's all in anticipation of something big. The upcoming Samuel Oschin Air and Space Center, which will be Endeavour's permanent home. Outside the building, follow signs to discover ET-94, the external tank which carried propellants to power the Space Shuttle main engines. ET-94 is 154 feet long and has a diameter of 27.6 feet. It was intended to be used as a testing prototype but was later modified for flight. Let's head up to the third and final floor of the Science Center. Here, you'll get a chance to explore the captivating Fire Science Safety Exhibition where you can become a fire danger detective. You can walk through the Casa de Fuego and Apartment 911, uncovering potential fire and burn hazards to enhance the safety of families, pets, and home. On the third floor, the high-wire bicycle suspends daring participants on a guide wire across the grand atrium for a thrilling experience. Brave visitors mount the bicycle, peering 43 feet down to the floor, embarking on a backward ride covering approximately 36 feet across the atrium before returning. Beyond the thrill, the exhibit serves a scientific purpose, teaching the law of center of gravity and showcasing the delicate balance between external forces and counteracting gravity. Safety is a priority with measures like seat harness and safety net, and participants must meet specific height and weight requirements. That wraps up our adventure today. I hope you had a great time. If you're ever in Los Angeles, check out the California Science Center. Enjoy what you saw. Show your support by liking, subscribing, and sharing. Share your ideas about where we should explore next, and stay tuned for more thrilling adventures.